work on this one. G of G at -1. All right, anyone want to be brave? What's G at G of -1? I thought it was 2 as well.
Yeah, it's 2.
Okay, G, okay, we got to work inside out. What's G at -1? 2. So now we've done one step. Now we have to find G at 2.
It's -1.
G at 2. Sorry. Oh, it is 1, sorry. I thought it was 2 when I read it the first time. G at 2 is 1. Okay, let's try a couple more. Let's try F at G at 0. And then try this one. Try F at 1. Okay. Okay, what's F at G at 0? I say -1, agree? Okay, so G at 0 is 1, and then F at 1 is -1. Okay, what's F of 1? Yeah, agree? Okay. All right, so let's try graphing now. Now, we found the information using table of values, right? Let's see how we get the information graphically. Given the graphs of y equals f of x, y equals g of x, determine the values requested below. So we have to flip over. Unfortunately, got bumped over to the next page. What if I just gave you the info from a graph? Okay, so here we have two functions. Here's your f of x. Here's your g of x. Now it's saying find g of f of 0. All right, so again, you're used to seeing the equations and just plugging values into the equations. So I suppose you could try and figure out what the equations of these functions are, right? Then you'd have your equations and you could plug values into the equations. What might be a quicker strategy to do, though, rather than figuring out the equations? If I want g of f at 0, okay, work inside out again. What's the value of f at 0? Let's see, here's my f function, right? F at 0 is 6, agreed? Okay. So g at 6, nine, right? Not reading the values from the table of values anymore, we're actually reading from the graph itself. So that's how we would read info from a graph. Okay? Conversely, this is also how you can graph the composition of a function. We can show you that too. So what's f of g at 1? Ooh, that's kind of hard, right? I think I'm going to have to... I'm going to change this one. Sorry, guys. How about f of... g at, I've got to pick something nice, 2. What's f of g at 2? And estimate your answer if you have to. I don't think it's 1. What's the value of g at 2? Let's figure that out first. This is your g is your parabola, so that's 1. So I'm looking for the value of f at 1. So what's the value of f at 1? Yeah, it's about 5.5, right? Right? So if you had to graph the composition of these functions, what you could do is just find, so we're going to do something else here too. I'm going to ask you to graph, let's see, f, g, let's call h of x. Graph h of x, and what h of x is, it's the addition of the functions f of x and g of x. Okay? That's what h of x is. So, what we could do again, we could find the actual equation if we could figure out what the equation of this f of x is, which I think we could. We could figure out the equation of the parabola. But a quicker way might be just to create a table of values. Okay? Normally I don't like the whole table of values approach, but think about it. If I can pick some values for x, so let's just pick a couple of values. Let's pick like a couple on the negative side. So how about, and easy ones to work with, I think. How about negative 4? Negative 2, 0. A couple of negatives, 0, and a couple of positives. 2 is nice. Give me another nice one. 4. Okay. So this gives us a range of values. First of all, think in your head, what will the addition of these two functions look like? If you add a parabola and a linear, what will the equation look like? You've got a parabola, so an x squared, and then you have an x. So what will the equation itself look like? It should be a quadratic, right? Because you're still going to have an x squared in there. So think about that it should look like another parabola. All right, so what I want to do is I'm supposed to add f of x plus g of x at all these values. So I don't know if we can do this. Maybe we'll show the steps. Okay, f of x is another name for y, right? G of x is another name for y. The only reason they're f and g is because they're two different y values, because they're two different functions. So if you just record all the y values here, and add them up, you'll have your new function, right? Without even knowing what the equations are. So what's the y value? I'm looking at f of x now. Maybe I'll highlight it. I'm just going to highlight this guy in yellow. So I'm looking at all the y values on the yellow graph. Okay, negative 4, what do I get? What's my y value? On the linear function, my y value at negative 4 is 8. Okay, let's move down to negative 2, 7. Yes? Am I right? Negative 2 is 7. What about at 0? 6. At 2 we get 5. And at 4 we get 4. All right? Let's do the y values for g of x. Once again, okay, now I'm just looking at the black graph, right? I've left the fluorescent graph, so let's look at negative 4. The parabola has a value of 4. At negative 2, the parabola has a value of 1. At 0, the parabola has a value of 0. At 2, the parabola has a value of 1. And at 4, the parabola also has a value of 4. So I just add these up and I get 12, 8, 6, 6, and 8. Okay? Yeah? Okay, so now what I'm doing is I am going to plot these points. Here's my new function. X and y, x and y, x and y, x and y, x and y. So negative 4 and 12. It looks like we'll be off the charts a little bit, so I'm going to add a couple of little. Here's my 12. So negative 4 and 12. Maybe I'll do it in a different color too. I'll do it in red. Okay, negative 4 and 12, negative 2 and 8, 0 and 6, so that remains, that's interesting. 2 and 6. So it's not quite a parabola, right? Something's weird here. Did I do that right? 0, 6, 0.
But x equals 1, it's a bit more than 6.
Oh, okay. So it's a bit over, so it's a little higher right here for this one, yeah. A little up, maybe. Okay, and then 4 and 8. Yeah, it's just a little, yeah, you think I didn't read my graph correctly, right? It's probably this one, right? Okay, so it looks like it's going to do this. This isn't quite a straight line. So that's what h of x looks like. Now, I didn't have to come up, it didn't ask me for the explicit equation. If they did, I'd have to figure out what this equation is and this equation. It just asked me the graph, so there you go. That's all you have to do. Now, if you're really good at this type of, if you're really good at visual stuff and seeing things, thinking abstractly, maybe you didn't even have to create a chart. You could have just said, okay, I'm going to pick my value at negative 4. I'm going to add these two numbers up and get 12, right? You could do it that way. I find that I don't easily see things that aren't there, so I have to always have data to look at. Some people are way better at this than others. But if you're trying to create a new graph, you're just adding the y values of the old graph, right? That's what you're doing. You're adding y values, or subtracting, or multiplying, or dividing. Okay? Questions? Pardon me? Yeah, Adam said I didn't, one is a little off, right? Which one did you say, Adam?
X equals 1.
When x equals,
Yeah.
but I didn't have a 1 though, I said 2. So I think this value here, yeah, it's right here. I think it's, Adam said it's like a little up from, like it's actually 1 point something, right?
No. I think x equals 1 is a bit lower than 6 than 1. X equals 1.
Yeah, but I didn't have 1 recorded here. I think this is where the problem was. I think here, if you look really closely, Johannes, maybe, I don't know, that kind of looks right, doesn't it? Yeah. Okay, so let's do x equals 1 then. Let's see what happens. When x equals 1, I've got g of x is like I'd say maybe even 0.3 even. And then I have 5.5. So I get 5.8. So at 1, we've got, oh, it actually dips down lower, right? It's about here. Oh, okay. So it actually looks like this, that's why. Thank you. That's why, Johannes. Like that? So the 6 is meat, but it's just the one in the middle. Okay. Okay, let's move on to page 8. Let's see, we're going to play around a little more, and then we're actually going to do some more graphing. And then I'm going to give you a hand-in assignment. So given the functions h and m, determine the values requested. So let's try these. This is good practice for us. So m of h of 4. So once again, find h of 4. So h of 4 will be what? The square root, h at 4 is the square root of 4 plus 5, which is 9. So h at 4 will equal 3. Agreed? So m at 3 equals 3 minus 1 all squared, which is 4. Yeah? Okay, try B. You're given a real value, so plug it in appropriately and come up with a real value. m at 13 equals 144, right? H at 149, I think. That's weird, right? Sorry. Sorry about that. H at 144 equals the square root of 149. Agreed? And that's it. We can't go any further because 149 doesn't have a square root, so that's it. We just leave it like that. No decimal answers unless you're asked for a decimal. Okay, let's try. These are a little harder. Just keep yelling out if you have a question or a comment. We're given two statements, a quadratic and a linear. Determine an explicit equation, just another equation for each requested composite function. State the domain. So this time we're not given specific values. So your answer is just going to be left in equation form, right? Because you can't go any further. So f of g of x. All right, so f of g of x is 3x minus 5. So I'll give you a sec to figure out what f of g, or f of 3x minus 5 equals. These ones are always a little harder, I think, when you're not given real numerical values. Okay, anyone want to share a final answer? Did you finish it, Carl? What'd you get? That's what I got too. So we both got 9x squared minus 21x plus 10. Yeah? So, because what I have to do first is I have to square this, right? And then 3 times this again. When you square everything and you simplify, collect like terms, that's what you should get as an answer. Okay? What about g of f of x? So g of x squared plus 3x. Well, g says I multiply whatever's in the brackets by 3, and then I subtract 5. So this one's a slightly easier one, right? So I get 3x squared plus 9x minus 5. Yes? Okay. One more. Do C, f of x. I think that's going to be a tough one again, because f of x involves the square.
It's plus 9. It's plus 9.
Sorry, this one? Oh, thanks. Thank you. do it, Eileen? Did you do it? What'd you get? No? Joanna, did you do it? What'd you get? 6x power 4?
No, that's
3?
x to the power of 4.
Yeah, I think I just started with, I got x to the 4.
It's x to the 4.
Yeah. And then 6x to the 3? Yeah, 6x to the 3.
Plus 12x squared plus 9x.
Perfect. That's what I got too. I got 9x. You got this too? Okay, well let's quickly do this then. We're in some kind of conflict. F of x squared plus 3x, right? Okay, so what do I do with f functions? I square what's in the brackets. And then I add 3 times what's in the brackets. So if I square this, I'm going to do this in my head. X squared times x squared is x to the 4. And then I have a 3x times x squared. I have 2 of them, so that'll be 6x cubed plus 9x squared plus 3x squared plus 9x. So here's my x to the 4. Here's my 6x cubed. These 2 are x squared, and then I do have a 9x. Those are hard to work with, right? It's much easier, I think, to work with numbers, like with real values. State the domain of each composite function. Okay, well, what would the domain of a quadratic be? Yeah, all real numbers. Again, all real numbers. Okay, this one, yeeks, I'm not sure. Actually, it would be it's a positive quartic, right? This one we'd have to graph. Because the quartic would have, this is a quartic, right? A quartic would have one of these guys, right? So it would have a minimum. So we can't determine without graphing technology. Good try. It would have, for sure, one of the intercepts would be 0. I just don't know. We'd have to use, I'm going to just say use graphing technology to determine. Oh, actually, no, we're just doing range or domain. We're not doing range. Never mind. Okay. So again, a quartic domain is just going to be, never mind. I thought we were doing range too, but you'd have to use graphing technology for range, right? Domain is just XER, right? Yeah. And like I said, for the for all of these, for the range, you'd have to use some kind of special technology. Okay, let's do a little more in graphing, and then we're pretty much done, I think. We're just gonna, I think we'll do the graphing one. I think I'll leave the restrictions, because we've already talked about restrictions. So combining graphically, now once again, you've got 2 options open to you. Just remember that you can always determine the equations of the functions and just work with them kind of algebraically to get the new function equation and then graph that. But honestly, the quickest way to graph when you're given graphs is just to pick out y values and combine the y values appropriately. So the graphs of f and g are shown on the same grid. Sketch the graph of the sum. So once again, and this is a really nice graph because they've clearly identified points for us even, the point. So half of the work is done for us, I think. So I think I would just do it the way we did before. So I would just pick x values that they've given us, what, 0, 3, 6, and 9? And represent the y values. This time it's another adding, and that adding them up will give us our new function, which we're just going to call y, I guess. Okay, so take a sec, record all the y values for f and for g. Spencer, at some point you have to go down and talk to John Howden, our guidance counselor. He has a message for you. Our guidance counselor,
Oh, okay.
he's got a message for you. Okay, so let's just check. I recorded my values. When x is 0, I got 6 and 2, or actually 2 and 6, I should say. When x is 3, I got 3 and 4, right? 3 plus 4 is 7, so 3 and 7. Whoops, sorry, thank you. I don't know what I did there. Let's check this out. And then when x is 6, I got 4 and 2, which is 6. And then when x is 9, I got 5 and 0, which is 5. So I got 0 and 8. I'm going to graph 3, 7. I'm going to graph 6, 6. And I'm going to graph 9, 5, which is here. So what kind of function do we end up with? Linear, right? Is that a big surprise to you that would be linear? No, because you added 2 linears, right? You're only going to get a linear. If you add 2 linears, you're going to get a linear. If you add or subtract 2 quadratics, you're going to get a quadratic. If you add a linear and a quadratic, you're still going to get a quadratic, right? Because you have that x squared term. Only when multiplying, dividing, pretty much you're going to get a rational, right? Unless you get one of those rationals where things cancel and you get a linear with a whole. So we kind of know what happens there. The only one that would be a big surprise, I think, is if you were multiplying 2 polynomials together. You don't really know. You might end up with a quartic like we saw a minute ago, or a cubic. Okay, so it doesn't ask me for the equation, so I'm good. I can just say that this is equal to y equals f of x plus g of x. Right? Let's continue. Let's do example 2, like the rest of these graphing, because we haven't spent any time on graphing at all, so let's do these as well. Also, just to become familiar with the shapes that you end up with. So here, what are we adding here? What do you see here? Part of a linear, right? A linear that's, so this is like a real life application, I suppose. It's just a quadrant 1 graph. So part of a linear, and this could be, it almost looks like part of a parabola, right? Or it could be an exponential that we haven't studied yet. All right, so I'm going to, again, our x values are nicely pointed out for us that we could use. 0, 40, 80. And this time we're subtracting. And we're just calling our new function y again. and it's h minus j. Remember, subtraction is not commutative. That means you can't, with these guys, it didn't really matter who I listed first and how I added them up. But here it matters because they want the h, the y coordinate of h, subtract the y coordinate of j. So I have to record h first. So it's going to be 20, subtract 10, right? You have to read your scales too. And then at 40, h goes first, so 40 subtract 20. And then at 80, I've got 100 subtract 30. So it looks like I'm going to get, I know it's not going to be linear. I think I'm going to get some kind of curved pattern happening again. So 0 and 10, that point stays. That point is invariant, right? That's what we call it. 40 and 20, that point is invariant according to the linear anyway. And 80 and 70, here we go. Here's where it starts to climb, right? So let's try one more, just because I don't know what's happening between here and here. Let's add one more point in to see if there's a curve there too. I don't know. So let's try to figure out what x at 20 would be. So h is 25, I think, and j would be 15. So I think it would be 20 and 10 again. So it looks like it is. It's linear for this part, which is very strange, and then it starts to curve up. Yeah. What, Joby? So what did I do? Did I screw up again? So when it's 20, I've got 25 and 15, right? Would be 10 again. Oh, sorry, 20 and 10. Sorry, thank you. So it actually dips below. That's interesting. So again, it looks like it's another kind of it's actually probably an exponential. It looks like it's half of a parabola, but we'll see in our next unit that that's actually what an exponential looks like. Okay, let's try one more. Or maybe two more. We'll do 4 as well. Then I'll let you guys go for break. So the graphs of H, F, and G are shown on the same grid. Sketch F times G. Okay. So they don't give us any points, so okay, so you guys are going to have to pull points out. Tell me what points you want to use. They have to be, I guess, right as we've known, fairly easy to read. So, what's interesting about this combination of graphs? What's interesting about F and G? Well, this one's radical inverted, right? But if I'm looking for function values, what do you notice right away when I said pick some values for x? What do you notice about this?
It's not known. There's no value.
Yeah, this graph, G only starts at 0, right? When x is 0, so I can't use any of these values. Does that make sense? There's no coordinating values. I can only start recording x, like the lowest value of x I can use is 0, right? Because there's nothing, G doesn't go past 0. The domain starts at 0. So there is no domain. You can only do function addition, subtraction, multiplication of functions where they both have x values, right? So I guess we could use x as 0, right? It looks like the next one we could use would be 2. Okay, is there another one we can use just to get a sense of this graph? Not really, right? Maybe 3? we'll have to estimate, right? 3. Let's try 3. We're going to estimate though a little bit. Okay, so we've got 0, 2, 3. That doesn't give us much to work with, but they didn't give us much. So the y value for f at 0 is 0. The y value for g is 2. Okay, at 2, the f value is 4. And on the g graph, it's 0. And then finally at 3, I have f has a value of 9, and g has a negative 0.5. Yeah, about that. Negative 0.5. Okay, what is that? That does not give us much to work with, right? So that's what, negative 4.5? All right, let's see what happens there. So we've got, just to keep us straight, this is what I'm graphing. 0, 0, 2, 0, and 3, comma, negative 4.5. Yeah, yeeks. I honestly don't know what this one would look like. I'm going to just check in at what 1 would be. When x is 1, we've got 1 times point, I'm going to say 0.8. I'm going to go a little higher than that, Adam. So it's 0.8. So this point is just going to stay. So 1 is going to be about here. So a little bump, and then down probably. That's my guess. Guess we could check it on Desmos too, right? So that's a really tough one too. It almost looks like it takes the shape of the half parabola, but then flips down. So I don't know. All right. But again, you would be probably, like for my purposes, as long as you know how to combine two linears or a linear quadratic, that would be good. When they have an exam question, I mean, they don't always on function composition, but it's usually two simple graphs that you would just have to combine on one, or finding the composite algebraically. All right, let's do one more because I think it's good practice for our rationals, because I see it's a division statement, and then I'm just going to leave lesson 4. I think you guys are pretty okay on this stuff so far. So the graphs of h and j are shown. So we have a parabola and an absolute value. On the same grid, sketch the quotient graph, h over j. Okay, so let's just see what this looks like. It should look like a rational function, right? So let's do x, h, j, and we're doing a division, knowing in our heads that it should end up looking like a rational graph. So we should get some kind of asymptotes, or right? Now, this is really interesting. I want to bring some points home here. J of x can't equal 0. Agreed? Okay. So, what happens when j of x equals 0? At values where j of x equals 0, was that you, John? Someone said the word. There is a vertical asymptote, right? Like there's an undefined value. So where does j, here's j is the parabola, right? This is where j equals 0, agreed? So where j equals 0, we know the new graph formed, the rational graph formed is going to have vertical asymptotes. It's only when you have rationals. So we've got vertical asymptote here and vertical asymptote here. So when I'm doing my table of values, I'm not going to find any values for -3, +3 because the graph, the y value won't exist there. It'll be vertical asymptote. So that also helps us when we're doing our graph of the new function. We know what happens there at these values. So I can only look for, I'm only going to include x values, certain x values, right? And remember that vertical asymptotes divide your graph up into sections too, right? So let's work over here. Let's find some values for like, again, I'm kind of restricted to it. And they're going to break our graph into positive and negatives too. So let's pick, I don't know, I guess at x equals -4. That's kind of like our test point, right? So at -4, h comes first. So that's my absolute value. So I have this value here. It's 4. So 4 divided by -4. Sorry. No, I guess it's going to be further down, right? It's going to be about here. Let's cheat a bit and say it's -8, okay? Let's say it's -8. So 4 divided by -8, I have a y value of -0.5, right? So at -4, my new graph is -0.5. So that means it's right here. So what do you think this graph is going to look like? And again, we're because I know that my vertical asymptote basically is going to divide my graph into positive and negative sections. So I guess this graph is going to end up looking like this, right? So that's this section. Let's go to the middle now. Let's look at some points here. Well, here's a point that I guess we could use. We could use this point. That's interesting. We could use the zeros. And we could use where they meet again. Okay? So would you agree that this is the point where both functions have the same y value, right? So if it's 2.25 divided by 2.25, it's going to be 1, right? So we're just going to drop down to 1. So this point will drop down to 1. This point will drop down to 1. And then when x is 0, let's figure this out. We've got h 0 divided by 9. That's just going to give me 0. Okay, so I have another point here. So I have this point, this point, this point. And I guess this point, it's allowed to touch a horizontal asymptote. So I guess this graph is going to look like this, right? Graphs can't cross vertical asymptotes, but they can touch horizontals. So I guess this graph looks here. Should have done my vertical asymptotes in a different color. Okay, one more section. Probably this part of the graph is going to end up doing one of these guys again, right? So let's see. Let's pick one more test point. I guess let's pick +4. We picked +4 before. So we have +4 gives me a 4 divided by, once again, it's going to be, we're going to say it's -8. That gives us -0.5. So once again, we've got our last little piece here. So that basically, the procedure is, if you're given two graphs, like the pictures of two graphs, just find y values at corresponding x values, do the math, and then you're just going to graph those coordinates, right? The x coordinate with the new y coordinate, and then your graph will develop that way. Always an alternative is you could actually figure out the equations, right? This is just the y equals absolute value of x. You could figure out the equation of a parabola. If they give you a good enough graph, right? Sometimes they may not give you a good enough graph in order to get those equations easily. So this is a quick way to do it too, right? All right. So that's add, subtract, multiply, and divide functions, and also composite functions and graphing with functions. These determining restrictions on composite, we've already touched on this a little bit too. So restrictions happen when you have square roots and when you have rationals, right, with your non-permissible values. I think I'll just leave that there. And that's it for operation.